dive in. So, does anybody remember from algebra? I know that might have been a while, maybe not, I don't know. How do you solve something like this? We got fractions. The main issue here is that fraction. What do you do? Let's get rid of fractions right away. If you got fractions, good to get them out of there. What will get rid of that fraction right away? Well, I don't want to do the reciprocal because that'll put fractions other places. I want no more fractions. Just multiply by the denominator. Just do the denominator. Just the 3. But you got to do all of them, right? Because when you have an equal sign, you got to do equal treatment to both sides, right? If they were equal before, you treat them the same. They'll still be equal, right? And it'll cancel right there. That's what I want. I want it to cancel out that 3 right there. And so, what will that leave us? That will leave us with 4x minus 12 is 3x plus. Now, what happens when the 3 here multiplies the root 2? Does it go, is it root 6? No, the 3 stays on the outside, right? Remember that rule? Outsiders stay outside, insiders stay inside. Is that good so far? Yeah. What'd you say? Oh, yeah. Yes, 9. Good. We good? All right, so now we're trying to get x alone. There's the wall. We got x's on both sides. What do we do? Got to just get rid of one of them. It doesn't, usually the lower one. Doesn't really matter which one. Boom, that's gone. So that's 4x minus 3x is 1x, or just x, huh? 3 root 2 like that. Last step. What do we do to get x alone? Add that 9, add that 9. Boom. So 1x, or just, x, is... Now, can I add that 9 and 3, 12 root 2? Is that correct? No. Yeah, remember the root rules? They got to stay separate. So it's just 9 plus 3. If that was 9 roots of 2 and 3 roots of 2, then they would add to be 12 roots of 2. Right? Remember that from algebra? When it comes, you know what roots? Roots are just like letters. Like roots, add, not like. This is like, if it helps you. This is like, if you're like, well, how do I know when they add and when they don't? That's like 9 plus 3y or something. You know how you wouldn't add that to be 12y? You'd say, well, those are unlike terms. That's the same thing for root. Roots are just like letters. If they both have the same root, you can add them. If they don't, you can't. Like roots or unlike roots is how you want to think about roots. So we're just done right there. Is that good? Remember that? It's a little algebra review. Make sure you're comfortable with that. Do a couple more. Good there. You remember that? Can you do that one? So what do we do with those parentheses? Multiply, distribute on through. Boom and a boom. 4 times 5 is 20x for root 2. Right? The outsiders stay outside, insiders stay inside. And then boom, boom. 5 times 9, 45. Oh, not root x. 45, bless you. 45x plus 9 root 2 is 13. Yeah, good. And then we combine like terms, huh? So 20x and 45x. 65. My 5s aren't looking so good there. 65x and 4 root 2 and 9 root 2. 13 root 2 is right, just like letters, like I was saying, right? These guys add, just like you would add 4x and 9x, huh? Get 13x. Its roots are just like letters. Equals 13. X is saying, I want to be alone over here. So what do we do next? Subtract 13 root 2. That's gone. Bring this down. 65x is 13 minus 13 root 2. Bless you. Now, what we can do from here, x wants to be alone. Yeah, we're going to divide, huh? Because that 65 is times, multiplied by the x, opposite of times is divide. So we're going to divide. Now, when you divide by the 65, remember you have to divide all of them, don't you? right? Whatever you do to one side, you do the other, all the terms, treat them all the same so you haven't changed anything. Now, calculator, 13 goes into 65. 13 goes into 65 5 times. So is the answer 5 minus 5 root 2? Is that right? No, I see that sometimes. What's wrong with that? Yeah, the 5s are on the bottom, aren't they? So watch out. Make sure you keep them where they're at. The 5s are on the bottom, so it's 1/5 minus 1/5 root 2. Right? Because the 5s are on the bottom. That matters. And there we go. We got x alone. This good? You remember all this algebra stuff? Was algebra your favorite class? I'm just joking about it. All right.
So for part C, can we just automatically add the...
Good eye, my. Yeah, you could just say 4 and 9 is 13 of those. Yeah, that would have been good. Yeah. Look how much easier that would have been. Yeah, nice. Yeah, you totally could have. And then subtract the root 2 and then divide by 5. Yeah, good idea. So distribute. Root x minus 6. Distribute. 5 root of x minus 15. What do you do when you got roots on opposite sides? Yeah, get rid of one. It doesn't really matter. I usually get rid of the lower one, but it doesn't matter. You could subtract 5 root x. It doesn't matter. So minus 6, that's 3 root of x minus 15. We good to there? X wants to be alone. So I add 15 to both sides. 15 minus 6 was at 9. Is 3 root x. What do I do now to finish solving for x there? Divide by that 3. Boom. And so root x is 3, right? 9 divided by 3 is 3. And then what do you do? Let me bring it over here for a second. So I've got 3 equals root x. What do I do to turn that into just like normal x? I don't want root x. I want normal. How do you get rid of that root? Yeah, 2 power it, huh? Right, 2 power square both sides, because 2 power is the opposite of a root, isn't it? That cancels out. 3 squared is 9. There we go. Is that good? 2 powers and roots are opposites of each other. You remember that from algebra? So x is 9. One more of these. Root x minus 7 squared is 4. Okay. Let's try that one. Let me, this one's a little tricky. Okay, so first off, how do I get rid of that root? What did I say, root? How do I get rid of that square? I root it, right? Now, hold on. There's a trick with that. I don't know if you know. Do you know you got to put plus or minus on the other side when you do that? Do you remember that? Let me prove it's true. You know, math isn't about memorizing little facts, about truth and logic. So just think with me logically, reasonably for a minute. What if you had something like x squared equals 9? What are the real answers to that thing? You know, aside from all fancy math rules, do this, do that, whatever. Just you tell me. What number squared is 9? What makes that true? What could you put in there for x, and that would be true? 3 or negative 3, right? 3 or negative 3, right? 3 squared is 9, that we know. But also minus 3 squared is 9, right? Because negative squared, negative times negative is positive. Either one worked. There's actually 2 answers to that, aren't there? So the answers to this are really positive 3 and negative 3, not just regular 3, huh? So, okay, great. So what? Why am I talking about all that? Well, what I'm proving to you is if you just put a root, which I know that's the algebra step, right? If you just put a root and you don't put plus or minus, you're going to miss one of the answers. You're only going to get 3, huh? So what I'm saying is that shows us that when you put a root on both sides, you've got to put plus or minus on the number side or you'll miss one of the answers. It's just clearly true from that example, isn't it? Do you see that? So that's why we do that. So when you put a root on this side, which is what we'll do because we got to get rid of that square, huh? You got to put plus or minus on the number side. That's just what's true. We can see from that little side example, right? So remember that. I'll write a little note on that. And I hope when you become an explainer of math, that you explain math like I just did, not by just saying, this is the rule, kid, just follow it, but instead appealing to their logic and just saying, isn't this true? This is true, right? So this is true, so this is true. That's all math is simply following what's true. Root, when you root both sides, when you root both sides, you must put plus or minus root on one side. So that's what you must do. All right, so what happens then? So over here, the rooting and the 2 power, they're opposites. They cancel each other out. And so all we get is the inside. We haven't touched that inside root yet, huh? Other side's plus or minus 2, isn't it? Now, what do we do with plus or minus 2? It's actually 2 separate equations. We just make it into 2 separate equations. We just say, okay, I've got root x minus 7 is 2, or root x minus 7 is minus 2. Good. And now we just solve them both. So add 7. So root x is 9. Other side, same thing. Add 7. And that's going to make root x be 5. And what's the last step to make it into like normal x in both cases? 2 power it? Yeah. 2 power, 2 power. So that's 81. 2 power, 2 power, 25. So we get 2 answers, 81 and 25. Both are true. Both are true. You can see it. We don't have a lot of time, but I want to show you what's true. Let me go back here to the beginning. This is back the way the question was originally, right? Before I started messing with it. It was like that. You can see that both those are true. Take the 81, for example. If I was to put 81 right there in the place of x, it's going to be true. What's the square root of 81? 9 minus 7? 2 squared? Yeah, 4. That's right, huh? See how 81 makes the equation true? And so does 25. If I put 25 in for that x, what's the square root of 25? 5. Take away 7. Negative 2 squared. Positive 4. That's right. It's like the equation knew perfectly to make the inside positive 2 or negative 2 by plugging in 81 or 25. How did it know exactly to do that? Well, it's because we used logic all the way through. So it logically showed those 2 results. Make sense? We're good in all that? A little algebra review? Questions I can answer? All right. Okay. So let me let you copy that down. So what's the deal? So do you remember these from algebra? How to handle these kind of problems? Kind of? There's probably a lot of ways. I'm gonna basically write 2 equations. One of them, this is algebra, right? We're doing a little algebra review here. This is the last part of the course, is a little algebra review. No, first off, the first equation is going to have nothing to do with money, and the second equation is going to be all about money. That's pretty much how most people handle this. I never care what method you do. Any method is fine with me. So, first equation, nothing to do with money. We have student tickets and non-student tickets. Why don't we make it S and N? You can make it X and Y, but I'm going to use S and N. That way I'll know what they are right away. So the number of student tickets plus the number of non-student tickets equals how many tickets? 782, huh? See, that equation doesn't have money in it. That has nothing to do with money. That's just total objects. Nothing to do with money. And then the second equation, you bring in the money. So if S is the number of student tickets that were sold, maybe it's, I don't know, 400 of them or whatever. How much money did they get for selling those 400 student tickets? Yeah, times 6, huh? Just got to multiply by 6, right? So it's going to be 6S. That'll be the total money they get from selling all the student tickets. And if N is the number of non-student tickets they sold, maybe 300 or whatever, then the money is $9 times the number of non-student tickets, right? They're $9 each. Equals, and then just the total money, huh? $55,649. Two equations, two letters. I don't know if you remember from algebra, but if you have two letters, you got to have two equations. If you have one letter, then you just need one equation. So when you have two letters, you need two equations. Does anybody remember how to solve these things from algebra?
You get one of the variables by itself and one of the equations.
Yeah, that's a good way to go. There's that, or there's the addition method. I don't care which way. Yeah, for most, I've noticed most people like to just get one of them alone and plug into the other one method. That's what so that's what I'll do. So let me write a note for you. So take the easier equation. Which one's easier? The top one for sure, huh? Because it has less involved. So take that easier one, bring it down here, get one letter alone, it doesn't really matter which one, and plug into the other equation. So take the easy equation, so the S plus N equals 782. Get one of the letters alone and then plug that into the other equation. So how do I get one of the letters alone? I'm going to subtract N from right, doing the same thing to both sides of the equation. So S is 782 minus N. Remember that? And then I'll take that, 782 minus N. Yeah.
Wouldn't it be easier to just have it equals the question asking about students?
Yeah, you're right. You're totally right. I'm purposely doing it the dumb way. I don't know if you believe that at this point, but you're right. Your way is better. I want to purposely do it the bad way so I can show worst case scenario to everybody. But you're right. You see what she's thinking? She's thinking ahead of time, and she's thinking, wait a minute, Mr. Heron. They're asking us for how many student tickets. So we want S in the end, don't we? So wouldn't it be better to solve for N, and then you'll end up getting S right away? Yeah, she's right. That would be smarter. I can still get it. I'm going to have one extra step. I just wanted to show you worst case. I didn't want to show you the super quick way, and then suddenly you get confused when you don't happen to get it as easily. So I'm showing you worst case. That would be better. To get N alone here, you'll see. All right, so we've got S. So what am I going to do with that S now? I'm going to plug it into the other equation. That means I'm going to take this, and I'm going to put it in right there. Plug it in for S in the other equation. It's only going to be one step harder than the other method. It's not a real big deal. Is that good so far? So I'm going to plug it in right there. So you get one letter alone in the easy equation, plug it into the hard. So I'm going to rewrite it here for you. So it's 6S plus, what was it? 9N is 5649. 5649. And then I'm plugging in S. S is 782 minus N. So S will be 782 minus N plus 9N. Does that make sense what happened there? Right, everybody see that? Because S is equal to 782 minus N, I can replace S with that, because that's what S is the same as, right? Okay, and now we have, why is that beneficial? Now we have an equation that just has N, only one letter, so we can solve for that letter. It's a little painful, but we can do it. So I'm going to do it. So I'm going to take this 6 and distribute. Definitely need a calculator. 6 times 782. I'll use my little thing here. some big number. I'm getting 4692 minus 6n plus 9n is 5649. Trying to solve for n, so let's subtract the 4692 from both sides. These guys right here, 9n minus 6n is 3n, huh? And that is 957. Good to there. Last step, divide by 3. $319. 319. Now, like Giselle was pointing out, I didn't do it the easy way. So now I got in, but they're asking me back here in the question, they're saying how many student, they want S, don't they? It's not a 5, that's an S. They want S. So how do I get S? I've got N is 319. How do I get S? What would be the easiest way? Yeah, or just say, hey, there's 782 tickets total. Which is the same thing as plugging in the first equation, basically. There's 782 tickets total, right? And I know how many were in, so just do what? Subtract from 782, right? 782 minus 319. See, put 7, put a 1, 3, 6. 463 student tickets must have been sold. So I had to do that little extra step because I got in. It would have been smarter, like Giselle was saying, to go the other way, to get in alone here and then plug in. I would have had S right away. But it's not a big deal. You just subtract the n from the total. Is that good? You remember that? And now it's fine with me if you want to do guess and test or any method. I don't care. Guess and test. I've shown some of that earlier. I don't really have time, so be glad to show you that. Come to office hours anytime. I guess there's no more office hours before our test. But yeah, there's other methods. I just don't have time to show them. Anything I can answer on this one? Is this making sense? You remember this from algebra, sort of? There's also the addition method. Anyway, there's a lot of methods. That youngest is not the favorite child. All right. So the estate is $643,000. The oldest gets 2 times as much as the youngest. The middle gets $14,000 more than the youngest. The youngest was the black sheep of the family, I guess. All right. Then the question is, how much did each person get? So what are we gonna do here? How are we gonna do this? There's a lot of ways. How about I go over here on the side and I write oldest, middle, youngest. And what I could do, see how they're all referring to the youngest? So what I could do is I could call the youngest Y. How about that? I mean, you could use X, but Y would be convenient. Remember it that way. Youngest, Y. And then I can write an equation for middle and oldest, huh? Or, I mean, a formula. It's not really an equation. A formula. So, middle. What's the middle? 14,000 more than youngest. So, what's the formula for middle going to be? If Y is youngest, middle's 14,000 more than youngest. So, what is middle? Yeah, 14,000 plus Y. Or you can put the Y first. The order doesn't matter. You can go Y plus 14,000 or 14,000 plus Y. Either way, it's all good. Oldest, 2 times as much as youngest. 2 times Y, not 2 plus Y, but 2 times Y, right? So there we go. So we have these 3 formulas. What are we going to do now with those 3 formulas? Yeah, they got to add up, huh? So we got to take 2Y and 14,000 plus Y, right? Oldest, middle, and then the youngest, don't forget the plain Y, and that equals 643,000. You can read that all there. Sorry, I got a little scribbly. Clean that up a little bit. Yeah, so there's the oldest, the middle, and the youngest. Don't forget the last Y. We also need the last Y, huh? So there's all three of them. They have to add up to be the whole money, 643,000. All right, we got a little bit, because this is easier than the last problem. There's only one letter. Right, I'm only using one letter instead of two, so I don't need two equations. Just got to solve this. All right, like terms, huh? Remember that? 2y, 1y, another y, 4y, plus 14,000 equals 643,000. What do I do next to solve for y? Subtract the 14,000. Um, 629, I think. And then divide by 4. And that one I don't know. 629 divided by 4. What is that? That's 157, comma 250. That what y'all getting? So that's how much the youngest got. That's y, huh? That's the youngest. 157,250. That's a pretty good deal still. The youngest shouldn't complain too much. And then how do you find the middle and the oldest? We just plug back in. Is that okay if I just move on? Just plug right in there, add 14,000, you get the middle. Plug right in there, multiply by 2, you get the oldest. Questions on that one? All right, if you're good, let's get that copy down. It'll be on YouTube if I'm going. So there's the question. So you got an 8-foot board cut into 3 pieces. 2 are equal length. The other is 6 inches shorter than any of the other 2. How long is each of the pieces? So maybe a little picture would help. So we have an 8-foot board. So we're going to cut 2 equal length, maybe, I don't know, like that long, yeah, maybe a little bit longer. 2 equal length, like that long, yeah, that's too far. Maybe like that, and then a short one. 2 equal length and then a shorter one, right? Okay, so what should we do? I give you P. My P's don't look so good. So how about I do X? It might look like a 6 or something funny. So I'll do X. But yeah. How about X and X and the other one? X minus 6? That good? There's one small mistake, isn't there? Janelle, what is it?
The 6 is 6 inches, and you're actually measuring in feet.
Yeah, only thing to watch out for there. That's perfectly great, good, except for careful. They switched up units on you. I hate it when they do that. Just seems like it's unfair. We got enough to worry about without them playing unit games. I'm helping my daughter with physics this semester, and it just drives me nuts when they go centimeters and meters and millimeters. I'm like, come on, guys. I'm just struggling with the formulas. Just give me the same units. So yeah, they're playing games on you here. So you got to get it all in the same thing. So yeah, 6 inches is how much of a foot? That's a half a foot. Let's just do it all in feet, huh? Or if that, well, maybe that bugs you. I don't know. I think it'd be easy. Just make it 0.5. Decimals are not bad to deal with, right? Just make that 0.5. Now you could change it all to inches, but I think that'd be a pain. Just make it x minus 0.5. It's half a foot shorter, right? 0.5. Decimals are not bad to deal with, right? Yeah, that's it. And now what? So that's a nice setup. Now what do we do to write an equation? Yeah, they all add up, huh? X plus x minus 0.5 equals 8. Huh? They have to add up to be the total 8. Is that good? All right, let's solve that thing. 1x, 3x minus 0.5 is 8. How do we get x alone? add that 0.5. This is gone. 3x, bring it down. 3x is 8.5. Kind of running out of room there. Bring it up here. 3x is 8.5. Last step. Divide by 3. I don't think that goes in nicely, does it? You're going to get an ugly answer here?
Wouldn't it be easier for inches though, because I think the answer has.
Oh, does it? I didn't look closely. Inches. They wanted it inches. You're right. Let's go back. Sorry, guys and gals. Let's go back. Let's do it in inches. Yeah, I didn't notice that they want the answer in inches. So I'll do it in inches. So this should then make this x minus 6. Yeah, we'll just say inches now. But then 8 feet times what? 12 inches in every foot is 80. 96? Yeah, I guess that is easier, huh? 80, 96. Yeah, so they add up to 96, don't they? So we'll just do the whole problem in inches. Forget about my decimal and feet and all that, right? Just do the whole problem that way. So, all right, so what do we get then? We get x plus x minus 6 equals 96 total inches, doesn't it? So that's 1x. That's 3x minus 6 is 96 total inches. Add 6 to both sides. And we get 3x is 102. Bring it over here. 3x is 102. Last step to get x alone. Divide by 3. X is, I don't know, 33, 34? 90, and yeah, 34. So x is 34 inches. So how long are the three pieces? This one's 34. This one's also 34 because that's what x is. The last one is 34, take away 6, which is, what's that, 28? 28 inches long. Good. Is that okay? Questions on that one? Having fond memories of your algebra days? Box contains 72 coins, dimes and nickels, a 580. How many nickels, how many dimes in the box? Okay, so let me rewrite it. 72 coins, dimes, nickels, 580. So 72 coins, $5.80, dimes and nickels only. Dimes and nickels only. They get all those facts right? 72 coins, 580, dimes and nickels only. Okay, so what should we do? Can you write a couple of equations? I bet you can, right? Because this is a money problem. This is just like the student ticket one. This is a money problem. So your first equation has nothing to do with money. Your second equation is all about money. Right? How are we doing? Those working out? Dimes plus nickels is 72. That good? Now that one's the no money equation, right? That's just treating dimes and nickels purely like objects. Adding them up, 72 total coins. And the next one, we're going to bring the money in. So you put the monetary value of dimes, 10 cents each, nickels, 0.5. Make sure not to put 0.5. I see that mistake every now and then. You know, it's 0.05, not 0.5, right? Is 580. That good? Total monetary worth. Like that. So there we go. There's our two equations, two letters. How do we solve it? Same way we did before, right? Take the easier equation, bring it on down, get one of the letters alone. In fact, I could probably push it off to the side here. There's probably enough room. So yeah, so get one of the letters alone in one of the equations. So just take it over here. So D plus N is 72. You could just subtract N, huh? And you would get D is 72 minus N. That good? So you get one of the letters alone in the easier equation, and then grab that and plug that in to the harder equation. So plug that in for D right there. D is 72 minus N. So then what do we get? We get 0.10 times D, and D is 72 minus N. Plus 0.05 in is 580. All right, so now can we solve that thing? It's all in, right? Yeah, distribute. So boom, boom, use your calculator. 7.2 minus 0.10 n plus 0.05 n is 580. So what's that going to be? Minus 0.10 n plus 0.05 is minus, right? Minus 10 cents plus 5 cents is minus 5 cents. N is 580. We good right there? See what happened? Just like terms, minus 10 cents plus 5 is minus 5. N, 0.05 n. Got to solve for n. So keep going. Subtract the 7.2 from both sides. Minus 0.05 n is, I don't know, is it minus 1.4? 6.8, yeah, minus 1.4. Almost there. Last step to get n alone. Divide by, I'm kind of running out of room. I'm bringing it up here. So I've got minus 0.05 n is minus 1.4. Last step is to divide by minus. Right, you always divide by exactly what's next to the negative sign, everything. Negative 0.05. And that's going to be 20. Is it 28? 28. Positive, right? Two negatives divided to be positive, huh? 28 nickels. How do we find out how many dimes? Just subtract from 72. I want to move on and set up the last problem for you in our last 2 minutes. This has been a long section. We good there? Questions I can answer on that one? So if you subtract, if you take 72 minus 28, what's that? 44? Dimes will be 44. Because 72 is the total, right? Total coins. So dimes are 44. All right. A farmer has 520 yards of fencing, blah, 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 for her goats. It's one side, river, blah, blah, blah. Side B is twice as long as A. Okay, so they're doing a lot of talking, but really it's 520 yards total of fencing. And see, this is A. I don't know if you can see, this is A. This side is A. This side is also A. And this side is B. Down here. And you don't need to put a fence on the top side because there's a river there. So we don't need it. So, and then they also tell me that side B must be twice as long as side A. So side B is 2A, isn't it? So it's A plus 2A plus A. A plus 2A plus A must be 520. And you just go on, dot, 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 solve for all here. I can just do it real quick. 1A, 2A, 1A, that's 4A is 520. Last step, divide by 4. A is that 250, 260, 130? 130. So A is 130. So length side A is 130. B is twice as long, 260. There we go.